class, let's go ahead and graph each system of equations to determine the solution. Let's start with the first one here. Remember, we're trying to find the solution to this. All right, to do this, I had to get a graph going over here, so let's begin. We want to make sure we put everything in Y-Intercept form, so we're going to change this up. I'm going to change it to be 4y equals, this x is going to have to go on this side, so we have negative x, and this is going to be plus 8. All right, when I divide, might not even have to divide. Let's bring this over here. This would be 4y. This would be equals a negative 3x. Okay, and then I guess plus 0. Don't really need to put that. When I divide this top one by 4, it's going to equal let's see, 4 divided by 4 is y. 4y divided by 4 is y. Negative x divided by 4 will be negative 1 over 4x. And then 8 divided by 4 will be 2. All right? And then on this one, 4 divided by 4 will give us y. And then this will be equal to negative 3 over 4x. We do that because we have to divide by 4 here, so we'll have to divide by 4 on this side. As we can see over here, we got negative 1/4, and it's crossing through 2. So I'll go to 2, 1, 2 here. We know it crosses here. And we know that it's negative 1/4, so that means it goes down 1 and over 4. 1, 2, 3, 4. So our line is going to reside there. That's our first line, and we're going to color that line. Let's color it this color here. All right, and now we're going to go to this one, which is negative 3/4, and going through 0. Remember, if there's nothing here, it goes to my origin, right? So if I put a dot, I'm going to put this one in blue. If I put a dot here, I said negative 3 and 4. That's 1, 2, 3, and 1, 2, 3, 4. Be my other dot here. When I make my line, once again, I'll go up 3 and then over 4. That'll put us here. And I'm going to make this line, let's see, I guess I'll make it light blue. And then we can see that the point at which they intersect is here. So that's going to give us, this is graph each system to determine the solution. The solution obviously is going to be, this is going to be negative 1, 2, 3, 4. So negative 4 is x, and then y would be 1, 2, 3. Positive 3. All right, let's go ahead. Number 8 is yours to do. I'm going to go to number 9. Number 9 says the total cost, C, of renting a canoe for n hours can be represented by a system of equations. write the system of equations that could be used to find the total cost, C, of renting a canoe for N hours. Okay, so we're going to write a system of equations that could be used to find, so we have some clues over here. The canoe rental for River Y is $33, right? Plain $33. River Z is $5 an hour, and there's a deposit of $13. All right. So let's see. If I wanted to write these, so when we write for River Y, since it's $33, you can simply say, let's see, this is for hours, right? River Y is just $33 plain. So the total cost of renting a canoe for N hours, we can say that the cost basically equals 33. We wouldn't have an N here because it doesn't matter the amount of hours. Once you go on River Y, you're paying that $33 for 1 hour or for 12 hours. Now let's go to River Z. River Z says $5 an hour. So remember, this is going to be River Y. And River Z is the cost is going to be equal to $5 an hour. So 5 times the number of hours, and the N is hours, so N. And then remember, plus a $13 deposit, so it's plus 13. All right, now it says graph the system of equations. If I graph it, the cost of my first one is going to be 33. These go up by 6, so 33 is going to be about halfway up, maybe about here. And then over here, 5n plus 13, we'd be at 13 for my intercept, right? And then 5n means I would go up 5 and over 1. So from 13 plus 5 would be 18. So that's up 5 and over 1. 1 is going to be about in between 1 and 2. And so if I graph this, it's going to go about like that. Okay. Let's see. Okay, and you might be thinking, what is 33 then? Well, 33 is going to be throughout, because no matter how many hours, I'm going 33. This tells me at about, when are they going to meet at 33? If it goes up 5, right, we have 13. We can say if C equals 33 and C equals 5n plus 13, we can write the 33 to make it equal, right? We graph it one with the cost. Well, this is graphing over here, right? This was the equations. So I guess I need to put this part down here. It says, when would the total cost for renting canoe be the same? I could say then that 33 to make it equal to 5n plus 13. Now I have to subtract 3 from both sides. 33 minus 3 is 30. Now 30 equals 5n. I have to divide 5 away. Whatever I divide from one side, I divide from the other. This tells me 30 divided by 5 is 6. Okay, so at 6 hours. So I guess I made this a little off because at 6 hours is when they should go ahead and meet. So I'm thinking I made this a tiny bit off here. Let's see. And it could be that, let's see, let's take the line. And I guess it would be more like this. And so, yeah, that's, I guess, about right. That dot there is really about right here. And yeah, 2's over here, so that's about middle. So yeah, that's where it would be for graphing, and that would be 6 count is my answer. I'm going to number 11 now. Graph the system of equations and estimate the solution. If I estimate the solution, remember, if y equals this and y equals this, then I can say that I can find, it says graph the system, so I'm going to have to graph this. Let me go ahead and grab a graph. All right, now that I got a graph here, let's go ahead and do this. Y equals 1.5x plus 1. Well, plus 1 would mean that it crosses through 1. And then it says 1.5. So that means it goes up 1.5 and over 1. So up 1.5 and then over 1 would be about here. And then up 1.5 and over 1 would be about here. So when I graph this line, it's going to look like this. Okay. All right. Next, it says that I have, let's see, 5.5, and if I go up here, this would be, what was this? Yeah, that was 1. So 1, 2, 3, 4, 5, and then 0.5 would be right here. And now it says minus 1.5, so I'll go down 1.5 and over 1, down 1.5 and over 1, down 1.5 and over 1. And this time when I make my line's going to come and run through these guys. So where is our point of intersection approximately? If I look at this, I see they're crossing through right here. That tells me, let's see, 1, 2, that's about 1.5 and 3, right? About 1.5 and 3. That's what I would guesstimate. 1.5 for x, and then 3 for y. In all actuality, when I look at this dot, it looks to be a tiny bit higher than the line. So it's probably going to be a little bit higher. If I had to be specific with it, I would probably say, let's go ahead and put these equal to each other. And that would give me, let's see, 1.5x plus 1 has to be equal, because these are both equal to y, to negative 1.5x plus 5.5. When I go to solve this, I can say that, well, let's go ahead and get our numbers first. I know that I'll have to subtract 1 from over here, which means I'll subtract 1 over here. I'll also have to bring, if I'm bringing my numbers here, I'll have to bring my x terms here, so I'll have to add 1.5x over here, which means I will add 1.5x over here. (1.5x plus 1.5x equals 3x. that has to be equal to 55.5 minus 1, which is 4.5. Now I will divide by 3 to get x by itself. And now I have to figure out, I'm going to have to figure out what 4.5 divided by 3, that's equal. That's going to equal to 1.5. So we were correct in thinking this is 1.5. Now that I know that, I can plug 1.5 in for x and solve for y. Let's watch over here. I'm going to take this first one where it says y is equal to 1.5x. But since I know x is equal to 1.5, that means I'm going to multiply this to 1.5. And then I'm going to add 1. Okay? So what is 1.5 times 1.5? Let's set that up here. 1.5 times 1.5 gives me 2.25. Now I have 2.25 plus 1. And of course, when I line up my decimals, that'll give me 3.25. And that's what I said, it's a little bit higher than 3. So if I had to be exact with this, I guess I can say even more than saying it's 3, it would be 3.25. Okay? All right, now I'm on number 13. Is graph and determine the solution of the system. I'm going to need another graph here, so hold on. All right, brought a graph in here, and I'm going to make all these in increments of 5, okay? They're no longer in increments of 1. When I do this, I can go ahead and solve for my system here. I believe I was doing the odd ones, right? Yeah. So in this one here, I got to regroup and make this into y equals mx plus b. When I do this, I'll have 5y equals negative x. And then for my second one, it's already set. 25y equals negative 5x. So when I divide by 5 here, I'll get y equals negative 1 over 5 x. And then when I divide by 25 here, I'm going to get y equals negative 5 over 25 x. Now this is kind of unique because remember I can divide by 5, by negative 5 divided by 5 will be 1, and 25 divided by 5 will be 5. So in reality, I can turn this fraction here into negative 1/5 x as well, which means these lines are identical, right? It says to graph them, so both of these are going to be the same. They don't have a y-intercept, so it starts at 0 and it goes down and over 5. So I'll go down 1, this is 5, right? And then go over 5. Actually, going down 1, I'm going to have to redo this. I thought I'd be able to go by 5s, but looks like I'm going to have to keep it at 1s. And this would be going down 1 and over 5. 1, 2, 3, 4, 5. And that means I'd be going 1, 2, 3, 4, 5 here. And this line, since it's negative, it's going to run from here through here. And since they're both the same, It's an infinite amount of solutions. Determine the solution, infinite many solutions. Okay. Um, and estimate the solution. Where do you do that? That was one solution. So number 4 is yours. 14 is yours to do. So that is all my homework. Good luck, everybody, and I'll see you in class.